All right, so here's a video on forces and components. Now, forces are vectors, so that means that forces have a magnitude and direction. All right, and when you're talking about forces, the main part is understanding the directions. All right, so forces can go up, they can go down, they can go left, they can go right, or they can go in some type of diagonal motion. And it really gets tricky once you start talking about forces in a diagonal motion or forces at a angle. All right. So let's say that we have a uh, a 2 kilogram block here. All right, and the block is accelerated with some type of acceleration of 2 meters per second. What would be the total force in the x and y direction if this block was forced up? Okay, we're going to neglect friction and air resistance. We're just going to talk about gravity and the other forces that are present here. Okay, so again, we have a block with a mass of 2 kilograms, and it has some type of pushed acceleration of 2 meters per second. All right. So we know that this block is on Earth, so we have to consider the gravitational pull on Earth, which is negative 9.8 meters per second squared. All right, and I think that's it. All right, so let's go ahead and find all our other forces. So we know we're going to have forces in the x direction and forces in the y direction. Okay. All right, so let's draw the forces on this block. So we know that gravity is pushing down on it because it's laid rest on the surface, Fg. And gravity is just the mass times the negative gravitational constant on Earth. So that's just going to be 2 kilograms times negative 9.8 meters per second squared. All right, and if you total that, that would be a negative 20 newtons. We know that there is a normal force that is pushing the block up, F normal, and that is going to be the mass times the gravitational constant, which is also similar to the weight, but it's positive. So this is going to be the opposite of what the weight was, which is positive 20 newtons. And then here we have a force applied that is pushing the block. So that's going to be FAP, which is just the mass times the acceleration. Put that. So the FAP, or force applied, is going to be the mass times the acceleration, which is 2 times 2, which is 4 newtons. All right. So like I said before, forces are vectors, and forces can go in left, right, up, and down directions, but they can also go at an angle. And when a force goes at an angle, you need to consider its components. All right. So we have this force applied that is pointing in the northeastern region. So it's going to have a component going in the east direction, and the north direction. All right, and so it's going to look something like this. Pretty much you're going to just make a right triangle. And a right triangle is just a triangle with a L or a right angle inside of it. And this is the right angle here. So this force vector, this force FAP, has a component going in the east direction, and it has a component going in the north direction. And we can classify those components with respect to the angle here as FAP X, Y, and FAP X. And when you do the trigonometry, I'm just going to do it. When you do the trig, this equation y becomes FAP sine of theta. And let's say theta is 20 degrees. And this one becomes FAP cosine of theta. Yep, because this is adjacent, this is opposite. All right, and so let's go ahead and calculate it. And we're not going to fully calculate, I'm just going to just give you the total forces. All right, so this is going to be 4 newtons times sine of 20 degrees. And this is going to be 4 newtons times cosine of 20 degrees. All right, so let's go ahead and list all of our X and Y components. So in the X direction, we have one force going right, which is F normal, 4 newtons cosine of 20 degrees. And it's moving, so it's going to be equal to some type of mass times acceleration X direction. And we have these two Y components, which is going to be positive force normal, which is 20 minus gravity. And the total net force in the Y is going to be 0. Okay, so if we were, no, and we're forgetting one actually. I forgot about the, it's going to be 0 plus this Y component here, which is the 4 Newton sine of 20 degrees. And this is also going to be equal to some type of value. All right, so essentially what we just did here is that we drew all the forces that were contributing to the motion of this block. And when you break the physics down and you show essentially like what these numbers mean, and you give it value, it starts to really make sense. What this is saying is that the only forces that are contributing to the motion of this block is going to be from this component here and this component here, which makes sense because the block is being pulled from a string. So all of the force is coming from these two components here and not these forces that are in equilibrium. All right, so these forces are not contributing to the motion, but these two components are. All right, and so that's just a quick example of, on forces and components. Stay tuned for the next video.